Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit and today's lecture is the generators. In the generators, we discuss the classification of generator. First is the AC generator and second is the DC generator on the basis of its output. So, we discuss the AC generator that converts the mechanical energy into the electrical energy, and what are the various components or the parts in the AC generator we will discuss further. So, the various parts of the AC generator are the field, armature, prime mover, rotor, stator and the slip rings. So, we discuss one by one. So, discuss one by one what is the rotor. Rotor, that is the armature also. The rotor often called the armature, and it is a coil of wires mounted on an axle. So, it is rotating part of the generator responsible for cutting through the magnetic field. So, this rotator moves and it cuts the magnetic field and inducing an electromotive force, that is a EMF, and that works on the principle of the Faraday's electromotive force. So, and generating the electric current. So, the rotor, that is armature, that is a coil of wire mounted on an axle, and that is the rotating part of the generator that cut the magnetic field through inducing an electromotive force and generating the electric current, that is the rotor. Next is the stator. What is the stator? The stator is the stationary part of the generator that surrounds the rotor. It means rotor in between the stator. So the stator having the rotor in between it. So, it is a stator is a stationary part. It typically consists of a core made of laminated iron or the steel sheet, and the houses the stationary coils of the wire. The stator provides a magnetic field in which the armature rotates. Next is the field winding. The field winding are the coil of the wire that are the part of the stator, and they are responsible for creating the magnetic field within the generator. So, this magnetic field interact with the rotating armature to induce an EMF. It means when this rotating armature or rotating conducting coil is in between the magnetic field, that will induce an EMF, and that induced EMF generate the electrical current. So, field binding can be connected to an external power supply, that is the external power supply like battery or the another generator, to establish the initial magnetic field. So, field winding are the coils of wire that are the part of the stator. Next is the slip ring or the brushes. What are the function of the brushes and slip rings? In some AC generators, especially those used in the smaller application, slip rings and the brushes are used to transfer the electrical power from the rotating armature to an external circuit. So, this slip ring and the brushes passes the power from one devices to the external circuit. So, slip rings are mounted on the rotor shaft and rotate with it, while brushes maintain the contact with the slip rings to collect the generated electricity, and that electricity we will get in the form of the output. So, function of the slip ring is with the rotating shaft, with that rotate with the rotator, and while the brushes maintain the contact with the slip rings to collect the generated electricity. Next part of the AC generator is the voltage regulator. That is also that is the optional part. In the modern AC generator uses in the power generation and the automotive application, a voltage regulator is often included. This device regulates the output voltage to ensure it remains within the specified range regardless of the variation in the load or the speeds. If we want a output in a specific range, then we use the voltage regulator. This helps to maintain a stable and a consistent electrical supply. So that is the optional part. Next part is the bearing or the supporters. Bearing and the supporters are used to hold the rotor in place and allows it to rotate smoothly. Bearing smoothly within the stator. It means the bearing will be put in with the rotor so that it will make the smooth rotation of the rotor. The proper bearing and the support structures are essential to minimize the friction and the wear in the generator. Next part is the cooling system, that is also optional. For the larger AC generator we use this cooling system, because in the larger maximum output, when we were having a larger output, so it uses a power plants and the industrial settings, a cooling system may be incorporated to dissipate the heat generated during the operation. So this ensures that the generator operates efficiently and prevents the overheating of the system. Thus we use the cooling system for the larger devices. Next is the housing or the casting or the casing. Housing means where we put this generator. So AC generators are typically enclosed in a housing or casing to protect the internal components from the environmental factors like dust and the moistures. The casing also provide the structure support and the safety to the AC generator. So the generator is packed in the some devices, some box, that is the housing or the casing. Next is the terminal box or the output terminals. This is the point where the generated AC power is made available for the external connections. So that connection is very important, that are the output terminal. It usually consists of the terminals or the connectors where the wires can be attached to transmit the electricity to the desired load or the distribution system. So these are the fundamental parts of the AC system. So AC generator are also known as the alternating in the devices convert of the mechanical energy to the electrical energy, and it comprises of the several key components and works together to generate the electricity. So these are the basic part of the generator. What are there is another part which is the slip rings, and these slip rings are used as a conductive rings and rotate with the rotator. So the various part we have discussed. Now these components work to convert the mechanical energy from a rotating source such as that rotating source into the electrical energy in the form of the AC output. So which can be used for the various applications, and the specific design and the size of these components can vary depending on the generator's capacity and indeed its use. Now how the AC generator works. Up to now we discussed the various components. Now how these AC generators works. As we know that we are using the rotator, we are using the magnetic field. So what is the function of the rotator in the generation of the electricity? Rotor coils or armature, the key components of the AC generator, and the coils of the wires often refers to as a armature, and this coil is typically mounted on the axle and can rotate within the magnetic field, and this magnetic field is stationary in the AC generator. The stationary magnetic field is created within the generator using either the permanent magnet or through the electromagnets, and this magnetic field is essential for inducing a electromotive force, that is the EMF in the coil. Next is the rotational motion. That rotator produces rotational motion. The armature is mechanically connected to the source of the mechanical energy. That mechanical energy may be from the turbine engine or from the hand crank. Then when the armature is rotated within the magnetic field, the magnetic lines of force are cut by the coil. and that causes a changing in the magnetic flux, and that depends upon that is the Faraday law of electromagnetic induction. That is, according to the Faraday law, the changing magnetic flux through coil induces the electromotive force EMF or the voltage across the coil, and the induced EMF that will be responsible for generating the alternating current in the coil, and the output current we will get through this coil. The alternating current produced in the coil is then made available as an output of the AC generator. So, this AC current continuously reverses directions as the armature rotates, resulting in the sinusoidal voltage waveform we can get. Now, how many types of AC generators? We define the AC generators are of two types. First is the stationary field rotating armature, second is the rotating field and stationary armature. So, stationary field rotating armature, we can define it as a small AC generator that have a stationary field rotating armature, and it has one major disadvantages of this type of generator is that the slip rings and the brushes assembly is in the series with the load circuit. And in the next rotating field and stationary armature, the alternating current will be induced into a stationary coil if the DC field excitation is connected to the rotor, and this arrangement is called the rotating field stationary armature, where we keep the alternating current induced into the stationary coil and the DC excitation connected to the rotor. It is mostly used with the high power generation of the output, and it involves the DC source applied to the field coils and will produce the magnetic field around the rotating element. And when the prime mover turns the rotor, then the field will cut the conductors of the stationary armature, and the EMF will created in the armature winding, and that is the, you see on the screen, that is the that is the AC generator. Define it as a, here the magnetic field is stationary and the rotor is rotating. So, this is the type, and both the type we can do it by applying the current or applying the output. Now, what are the advantages of the AC generator over the DC generator? The AC generator can easily step up and step down through the transformer. Second advantage is the transmission link size in the AC generator is thinner because of the step up features. Losses in the AC generators are relatively lesser than that of the DC machine. The size of AC generator is smaller than the DC generator. Most of us begin with the direct current, but eventually we learn that the direct current is not the only type of the current we come across. So, they are the sources of electricity that produce the voltages and current which are alternating in the nature. So, this type of current is called the alternating current, and the output we are getting through the generator is the alternating current output. So, AC generator produces the AC output that convert the mechanical energy into the alternating current. That is the AC generator. Up to now discuss the AC generator. Now the second type of generator is the DC generator. DC generator is an electrical machine whose main function is to convert the mechanical energy into the DC direct current into the electricity. So, when the conductor slashes, magnetic flux and EMF will be generated because on the electromagnetic induction principle of the Faraday laws. The electromotive force can cause a flow of current when the conductor circuit is closed. So, what are the parts of the DC generator? As a similar, the DC generator can also be used as a DC motor without changing its construction. Therefore, a DC motor can be DC generator. DC motor or otherwise a DC generator can be generally called as a DC machine. Then the various essential parts of this you see on the screen, that this is a DC generator. This is a flow of current here. We are having a two terminals, pole are here, rotating pole, and this is a rotor. Now, how does the DC generator works? According to the Faraday's law of the electromagnetic induction, we already discussed the current carrying conductor is placed in the varying magnetic field and an EMF is induced in the conductor, and that induced conductor produces the electric current, and it is in the form of the DC. So, according to the Faraday right hand rule, here we are using the direction of the induced current changes whenever the direction of motion of the conductor changes. So, we consider the armature rotating clockwise and the conductor at the left moving upwards. So, when the armature completes a half rotation, the direction of motion of the conductor will be reversed downward. So, direction of the current is every armature will be alternating, but with the split ring commutator, connections of the armature connectors get reversed when the current reversal occurs. Therefore, we get the unidirectional current at the terminal. You see here on the screen that how we rotate it. Axis of rotation you see here the anti-clockwise, but the wire coil conductor is rotating clockwise. So, we use the commutator and the carbon brushes here. So, sinusoidal output we are getting on the right hand side. You see that there is a output in the form of voltage. The magnetic field conducting carrying conductor. What are the losses in the DC generator? The output power is not fully transformed into the output power. The input power is not fully transformed into the output power in the DC machine. So, some part of the input power gets wasted in the various forms in the DC generator. So, losses are broadly classified into the 4 types. How many type of losses are there in the DC generator? We classify into 4 types. First is the copper loss. Copper loss, what is the copper loss? That takes place when the current flows through the winding, and these losses occur due to the resistance in the winding. So, the copper loss is characterized into 3 forms: armature loss, field winding loss, and brush contact resistance loss. So, copper loss are there because of the winding. Next is the core losses or the iron losses. Some losses in the iron core occurs when the armature rotates in the magnetic field. These losses are known as the core losses, and these losses are characterized into the 2 forms like hysteresis loss or the eddy current loss. So, in the core losses we have the 2 losses like hysteresis loss and the eddy loss. What type of the DC generators are? DC generators are 2 types. First is the separately excited, second is the self excited. So, the DC generator can be classified into the 2 main categories. First is the separately classified, second is the self classified. The self classified is again classified into 3 forms: series, shunt, and the compound generators. Separately excited, the field coils are energized from an independent exterior DC sources in the separately excited type generators, and in the self excited types the field coils are energized from the generated current within the generator, and this type of generator further classified into 3 forms: series, shunt, and the compound. What are the application of the DC generator? A DC generators are using the separately excited type DC generator are used for the power and the lighting purposes. Second application is the series DC generator is used in the arc lamp for lighting stable current generator and the booster. The DC generator are used to reimburse the voltage drop within the feeders. So, DC generator also used to provide the power supply for the hostels, lodges and offices, and these are comprehensive explanation of the DC generator. And then information about, we can conclude that the main advantage of DC generator is simple in the construction and in the design. Apart from this, the alternating, we can discuss the some of the synchronous generator, that is also known as the alternating current generator. The major reason of the selecting the alternating current for the power network is that continuously variation with the time allows the use of the transformers. So in that case we use the synchronous generator, that is a one type of generator. The major reason for selecting the alternating current for the power network is that its continual variation with the time allows the use of the transformation. that that device converts electrical power at whatever voltage and the current it is generated to the high voltage and the low current for a long distance transmission, and then transform it down to a low voltage suitable for each individual consumer, that typically from 122 to 40 volts for the domestic services. So, the particular form of the alternating current used is a sine wave, that is called the sinusoidal, or that is a synchronous, which is the simple, and because of it only the repetitive shape for which two waves displayed from the each other in the time can added or subtracted and have the same shape occur at the result. So, the ideal situation is that the voltage and the current of the output is the sine shape. The synchronous generator is designed to produce this shape as accurately as is practical. So, this will become the apparent as the major component of the characteristics of such a generator, and that is, now you see here this is a synchronous generator. You see we are having a rotator, we are having a stationary field, you see the magnetic flux lines are there and the field conductors and iron rotor, stator, that is also defined, stator conductors, and slip rings are defined here, iron stator and the connections that will give for the output. So, this is the schematic diagram of the synchronous generator. In this synchronous generator, the rotor, that is the basically is important part, that central shaft of the rotor is coupled to the mechanical prime mover and the magnetic field is produced by the conductors or the coils wound into the slots cut in the surface of the cylindrical iron rotor, and this set of the coils connected in the series, this is also known as the field winding. The position of the field coil in is such that the overwardly directed or the radial components of the magnetic field produced in the air gap of the stator, and that approximately sinusoidally distributed around the periphery of the rotor, and the output will be the form of the sinusoidal wave and in the synchronous manner. The field density in the air gap is maximum outward at the top, maximum inward at the bottom, and the zero at the two side, and that is approximately sinusoidal distribution. The one at the maximum and another is the minimum at the zero. Next is the stator. The stator is that is made of the iron to provide an easy path for the magnetic flux, and that stator, this a coil normally consists of a number of turns. So used in this case the stator contains only one coil, the two sides being accommodated in the slots in the iron and ends that connected together by the curved conductor around the stator. and when the rotor is rotated, the voltage is induced in the stator coil, and at instant the magnitude of the voltage is proportional to the rate at which the magnetic field encircled by the coil is changing with the time. So, the rate at which the magnetic field is passing the two sides of the coil, the voltage will therefore will be the maximum in the one side when the rotor has turned 90 degree from the position, and will be maximum in the opposite direction, that is 180. The waveform of the voltage will be approximately of the sine, and that will form the sinusoidal wave. And the frequency, the rotor structure of the generation, one magnetic flux directed outwards and corresponding one of the flux directed inward. The complete sine wave is induced in the stator coil for each revolution of the rotor. So, the frequency of electrical output measured in the hertz, therefore equal to the rotor speed in the revolutions per second. So, to provide the supply of electricity at 60 hertz, or the prime mover or the rotor speed must be 60 revolution. Revolution per second. So, now the per and the 3600 revolution per minute. So, this is converted speed for many steam and turbine engines. So, the required rotor speed for the frequency to generate the required output. In this manner, we can get the required output voltage in the form of the electric current. Thank you very much.